Hi and welcome to this tutorial on answering this question, which is a very interesting question, which is how can I make a snake robot with many identical segments, this is the important part, in SDF. And this user asks quite a lot of questions on how to do it based on this morphology and so on. And I'll try to make an example of how to do this, and to talk about a bit about how to create robots that have elements that repeat a lot. So answering the basic question is, can you do it with SDF? Well, you can do it with SDF, but it's a lot of work. And you have another option, which is Chakros, using Chakros, which uses URDF syntax, but basically in these type of models that have repeating parts, it's highly advisable that you use Xacros, because you can define one element and then repeat it as many times as you want. Okay, so I'll try to explain this step by step with an example. So the first thing is I'm using ROS Development Studio to do this. You can do it locally in your computer, of course, with a ROS installation, but I'm using ROS Development Studio, which is a web-based ROS development environment, and basically here you can do anything you can do in local computers. So the first thing I'm going to do is launch my code editor, and I'm going to put it like this. Okay, so I'm going to go to my environment. You can go to your Catkin workspace, and I've created this snake description package. If you have any doubts on how to creating packages, of course, go to other tutorials that we have about that, but we'll concentrate on this. So first things first, how can we do this? So I've created a launch file, which is init snake. In this init snake launch, I'm spawning the snake, and I'm starting the control. Okay, we're going to talk about those two parts, the spawning part, the model part, which is the most important part, answering the question, but also the control, because otherwise we don't have a functional robot that you can move around. Okay, so this tutorial will be divided into these two parts. So the first thing is spawn full snake. So we go to this launch, that is spawn full snake. There we go. And here we are using this spawn Chakra launch that needs the position that you want to spawn the Chakra robot, and well, the robot defined through a Chakra. Then we give the Chakra file itself and the name of the robot. Okay, clear till here? So let's have a look to spawn Chakra, which is this one. Spawn Chakra is very simple. It uses the Chakra command around here, so that you can transform a Chakra, this transform a Chakra to a URDF file, that it's loaded into this robot description parameter, and this robot description parameter is the one that is used to spawn the real robot, let's say, in Gazebo, which is this URDF spawner. Okay, and uses all the model name, the position, and the robot description, that inside you have all the data of how the robot is defined. Okay, until here, no problem. Okay, so let's close this. And let's have a look to this snake controllers URDF. So let's go here, and here we are. So this is a Chakra file. A Chakra file is used, it's very useful for very complex robots that you have to parameterize a lot of things. But the most useful, in my opinion, property of the Chakras is in the cases where you have a robot that has a lot of elements that are exactly the same and they repeat. Why? Because in Xacros, you define a macro, let's say, which defines a link. In this case, we are going to define these segments. So one segment is called body link. And we're going to stack all these body links one after the other, and we're going to generate a snake. So let's have a look. Let's not concentrate in this for the moment. So how do you do it? What you do using this Chakras is use this line. With this line, you spawn, it's like writing all this code for each line of these. So we've done 7, so this robot will have 7 segments, 7 body links. Understood from here? Okay. So, and how do we do this? So these Chakras have variables that you can change. And of course, if you want to do a multi-element robot, you need to change the name, for example, of the links. Otherwise, it won't work. The joints won't work, the transmissions either. And also if you want to change properties like colors or sizes and so on. Yep. So this model has this base link, which is just a cylinder with certain dimensions that will repeat in all the elements. But this base link is the only one that is defined through standard URDF. So it has an inertia that it's calculated based on the shape of this cylinder for collisions and for visuals. Okay, then we put the mass, and that's quite it. Then we defined the gazebo physical properties, which are the Kp and Kd and the frictions, and also the material, which gives the color. And this is very important in this case, is the self-collide, which we have to activate. Why? Because this snake, we want it to collide with other elements of itself so that it's realistic. Okay, so this element is defined like this. And basically the body link is more or less the same thing repeated 7 times. Okay, so let's have a look to the Chakra now, shall we? So here. So here we state the name and the parameters that we want. And we've defined 2 links inside this macro called body link. The first one is an auxiliary cylinder that we'll see just in a minute when we spawn the robot. This is one, and then the other one is the main element, and they are cylinders with different lengths and the same radius. Then we define the physics, properties with the colors. As you can see, the auxiliary is always black in this case. And then we define the joints, which are connecting to the parent name. The first one is connecting the parent name to the base name auxiliary, which is this one, base name auxiliary, which is the black cylinder that we'll see just in a minute. And then we have the next one, which connects the auxiliary, which is the black cylinder, to the base, which is the main cylinder that has the color that you stated. Okay, that it's this one. Okay, very good. And once you have it, you have to define also the transmissions. The transmission for the first joint and for the second joint, for the auxiliary joint and for the main joint. Okay. And as you can see, they have different axes because we want this robot to have in each joint roll and pitch so that it can move basically as a snake would. Yeah. And finally, you have to state this gazebo plugin, blah, 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 to get the control. Okay. Let's have a look how this works. Okay, so what we do now is launch first a simulation. So let's launch an empty simulation here, and while it's launching we can put a shell around here. And let's go here, ROS launch, snake, init. Okay, let me put this like this. Yeah. Okay, and let's spawn the snake. There we go. Whoop. Okay, so as you can see here, we have each element divided by this black ring, which is the auxiliary link that we had. So let's have a look to the code editor. So here you can see here, so this is the auxiliary ring. Let's have a look like this. Okay, now we have it. So here we have the snake, and here we have the auxiliary links, which is the black ring, and then we have the base one, which is the color. So the green one is, as you can see here, it's the base link is color green, and then we have the blue, the red, the purple, the white, the yellow, the turquoise, and the gray. Okay. So we have these 7 links here. So, and that's it. So we have now a multiple element robot with just these lines defined and one element. We define one element here in the macro. We define only this one, the blue one, and then we can repeat it again and again. We define the black and blue. Okay, this is all the Chakra element. It's the black element, auxiliary element, and the blue one. Okay. Okay, this is the first part. How do we do it? Like this. You define a Chakra, you define an element that you'll repeat again and again as many times as you want, and that's it. So that's the robot without control. Then let's have a look on the control. Let's have a look. Okay. So how did we do the control? So the control is here. So if we go back, we initialize it like this, we spawn it, and then we start the control. So let's have a look to the control. The control is very, very simple. So you load the param files, so that we have here in config, which is a YAML file. And here we state each and one of all the joints that we have. This is the only inconvenience of doing this repeated, that we can't parameterize this, as far as I know. If you know how to do it, please leave it in the comments below. And here you have to state the full name of each joint you want to control, and all the control parameters and so on. As you can see, there are 14 because there are 2 for each element, for each link and the auxiliary one. Okay, and here we have it. So we load this, and then we start the controller manager. We put all the names that we have here, so all these names. Have very present the namespace. It's really important. This is a source of errors. So the namespace here, also here the namespace, and in the YAML you have to put it also. Okay? This is one way of doing it. You can do it many ways, but this is the way that it should work. And once you have it, you put just a shutdown timeout of 3. When you delete the robot model, then it will stop the control after 3 seconds. And then we put the robot state publisher to publish all the TFs. Yeah. So in theory, you can see it in RViz. So we launch here RViz and the graphical tools that we'll put here. Let's have a look. Oops, let's put it here. Why is too much here? It's getting too messy. So here let's have a look. Yeah. Base link. Then we add the TFs, which are around here. There we go. As you can see, because it's based on the base link, then that's the orientation that for the base link it has. If we had some odometry of some kind, then we could orient this robot based on that. Okay, and let me have a look. Let's add robot model. There we are. So because we didn't state any RViz colors in the URDF, then it's all red. No problem here, because they don't match the gazebo colors with the colors given in the elements. No problem there. Okay, so we have in RViz also. So the only thing that we have to do now is move it. So to move it, you can do, let's move this to desktop number 2, so that here we can launch another shell and launch the RQT GUI. Let's run RQT GUI. There we go. And now we have to select all the controllers to move them manually. So I'll fast forward and we'll see in a minute, okay? Hello again. So here we have all the controllers with an expression here that it's sine of the time divided by 100. So this will make the values sent to this controller vary throughout the time so that we can see the robot moving. So once you have it, so as you can see, it's a lot and it's only 7 joints. So imagine if you have 20. So of course, the best thing is to do it in a program. So if you're interested in knowing how to do it, please leave it in the comments below. But yeah, so like this is a very good way to test if your controller is working or no. So if we activate it, let's activate all of them. And then we go to the simulation. There we have it. So as you can see, it's moving as it can because it's not an intelligent control, but it's moving. As you can see, it's moving up and down, left and right in each of the joints. If you want it to move faster, then we can just change this to, and there you go. Then it goes much faster now. But essentially it's this. And that's it. So going over what we talked about. So we have to generate a model that has multiple elements that repeat themselves. SDF is not the way to go. The way to go is Xacros. So Xacros will give you much more flexibility and it will make you much faster to implement and to add more elements, because if you want to add another element, you just have to put it here. Another one. That's it. And the only problem is that you have to, of course, know how to use Xacros. But once you have it, because you iterate over this very simple element, then afterwards adding more elements is very, very easy. Okay, so answering your question, this user's question, SDF is not the way to go. It's Xacros, and you have to use them because it's much more flexible. Okay, I'll leave the solution and all the code in the description and in this answer. I hope that this was useful, and that if you're interested in more content about robotics and this kind of tutorials, please leave a comment below and subscribe, leave a like, and that's it. Thank you and see you soon. Bye.